Good afternoon, everyone, and welcome to this new online conference that we have organized. These are the new series of young investigators for our coast action. And I think the aim of this conference is to give already a little bit of help for the new researchers to make themselves visible and to learn new techniques and new methodology. So we are starting this conference today with Nuria, but before talking about Nuria, I wanted to tell you that next month we will also have another conference. So it will be on the 15th of July. And this I will remind you at the end of the conference. So Nuria she studied biology in Madrid, in the Universidad Autónoma de Madrid. And later she joined the Master in Immunology at the School of Medicine in our university, in the Complutense University. And she did a research stay in my lab where she was very successful because she has published a couple of papers, and some others are also coming or on their way. And then she just moved to, recently, last year, she moved to Lübeck, to a city very close to Hamburg in Germany, where she has joined the molecular endocrinology program. And she's now studying a little bit more of focus on metabolism. But today she will talk a little bit about how she did this short-term scientific mission that we want to encourage everyone to do them, because it's a great opportunity for you to learn new techniques in any other lab from the community, from our Coast Action community. So we want you to apply and take action. So Nuria, whenever you want, you can start talking a little bit about how you move from Madrid to Prague to the laboratory of Oleg Lunov, and you started this short-term scientific mission, which brought a lot of very nice results. And I think that Laura is now wrapping up the paper. She's also in the audience, so we can discuss later at the end of the talk.
Yes, thank you very much, Javier. So first of all, thank you for inviting me here today, Maria Isabela and Javier. I am really happy to be here with you. So I'm going to share my screen and then, yeah, I hope so. So as Javier introduced me, I'm Nuria López-Alcántara, and I'm very happy to be here and to share my experience with you about my short-term scientific mission in Prague. As he said, I was a master's student in his laboratory. I also started my PhD there, and I was mainly focused in liver pathophysiology and liver disease and in fibrosis, especially in oxidative stress, working in the pathway KEAP1 and NRF2. I don't know if you know about it, but I'm going to do a quick introduction about the topic. This talk is really informal, so I'm not going to talk about results or anything like this, more about my experience and how is this a really nice experience, and I encourage you to do it if you have the opportunity. So my short-term scientific mission was in the lab of Oleg Lunov, and we chose it because of other reasons, because of the amazing technology that they had, the microscopy, and their experience in oxidative stress. So if you are working in that field, maybe feel free to contact him. Yes, so as I just said, first I'm going to do a first introduction of my master thesis. I'm just going to introduce it in the sense that you can get what I did and how I got to the problem and why I decided to do a short-term scientific mission and what was my motivation for doing this and going to Prague. Also, I will talk about a little bit about what I did in Prague, which was 2 weeks, I think, and the methods that I used in there. What's the benefit of doing a short-term scientific mission and how to apply for this short-term scientific mission. So first of all, what is chronic liver disease? So chronic liver disease is a progressive process caused by a continued destruction and regeneration of the liver parenchyma, that leads to fibrosis, which can further progress to cirrhosis. Oh, wait a second, maybe I can use, yes. Which can further progress to cirrhosis and furthermore to hepatocellular carcinoma. My master thesis and my studies during working in Javier Cubero's lab was mainly in fibrosis, which is a state that can be reversed and the liver functionality can be restored. So we were mainly focused in targeting this stage for possible therapeutic options. So we were studying how the oxidative stress is a main player in the development of fibrosis. When there is oxidative stress in the liver, there are many factors released out of this process that can activate the cells known for hepatic stellate cells. These cells are the main ones in charge of collagen production, and the production of this collagen is that huge that it ends accumulated in the liver parenchyma, and this is what it causes fibrosis. So as you can see in this picture, how a normal liver looks like, how a liver with fibrosis looks like is completely different. All the structure is lost and the morphology of the cells is completely changed. And also you get these fibers and also loss of endothelial fenestration. So we wanted to study how is the oxidative stress related to fibrosis. So first, what is oxidative stress? It's a disbalance between pro-oxidant response and antioxidant response. In normal conditions, the major player or the main one that is known to have a role in the oxidative stress response is the KEAP1 NRF2 pathway, not only in the liver, but it's important in the whole body, in every cells. And in normal condition, the NRF2 molecule is bound to the KEAP1, forming a complex that is at the same time bound to an E3 choline ligase, E3 ubiquitin ligase protein. So this what allows is to mark NRF2 for the degradation in the proteasome. And this is what happens in normal conditions because you don't have oxidative stress, so the activation of NRF2 is not needed. However, when there is an hepatic damage, this oxidative stress targets the cysteine residues of KEAP1, allowing a conformational change of the molecule, allowing the detachment of NRF2 that is a transcriptional factor, and this NRF2 can translocate into the nucleus and activate the transcription of many genes related to the antioxidant response. So this is the theory, and there are many research about this, and it's very controversial because some authors says that the overactivation of this pathway could be beneficial for liver disease, but some others says that in fact the overactivation of this pathway can lead to more fibrosis and to inflammation. So we wanted to be sure about the role of the oxidative stress during this whole procedure. And for that, our main hypothesis was that the KEAP1 NRF2 axis was important in hepatocytes, and in these cells are the ones that are controlling the development of hepatic fibrosis. For that, we developed an animal model which has a specific deletion of KEAP1 in hepatocytes, leading by the promoter of albumin, which is specific from hepatocytes. And we treat these animals with a corn oil or with CCL4, which is a known drug for developing fibrosis. It's already well-described model for liver fibrosis. So we treat the animals for 28 days and we sacrifice them after the 48 hours after the last injection. These don't be scared about the results. I won't show any result, but with this, I just wanted to show you that we proved that the levels of gene expression of KEAP1 were indeed produced in our model. So the conclusions of our experiment, because I have the slides, but I don't want to just show up all the results because maybe it's a bit overwhelming. and it's not the point of this talk, is that we saw that indeed the CCL4 induced liver damage and induced fibrosis in both groups, in the ones that didn't have the KEAP1 in hepatocytes and the ones that had KEAP1 in hepatocytes. Also, you may think that if we remove the KEAP1 from the hepatocytes, we should see an increased level of activity or activation of NRF2, but we didn't see that either. Also, the targets of NRF2, especially NQ01, which is the main one, was not overexpressed either. And we didn't see any difference in degrees of fibrosis, nor in staining or other or immunofluorescence. And the only thing that we saw is that when we deleted KEAP1 from the hepatocytes, this led to an increased immune cell infiltration. But also, and this was our main hypothesis, it was the role of oxidative stress during this whole procedure. And we didn't see any changes, any differences. So what was happening? If there are no changes in the chronic model, we thought that maybe an acute model could be better for us. So we start thinking in improving this in an acute model. And for that, first, before going to an animal model, as I was doing, you need to prove your theory in an in vitro model. For that, we wanted to do a knockdown for KEAP1 in cells, in cell lines, in hepatocyte cell lines, of course. And there we will study the oxidative stress and the mitochondrial function. But we had a problem. We didn't use, or at least I was not able to do this in an in vitro model. We didn't have the facilities, and I was not working with cells at the moment. So it's very important for you and for your future, and if you want to do a short-term scientific mission or any internship, is that you have an active communication with your PI. You must remember that you are a baby in the field, and they have the expertise and the knowledge, and you need to continuously share your results and have active discussions about everything, your ideas and your thoughts, and don't be scared, because sometimes crazy ideas leads to good places. So we also did some research and come up with some ideas that we could do to make this happen. And then we discussed also with our team possible strategies. I was very lucky here because Javier is the coordinator for the short-term scientific mission, and he knows all the research that is carried out in all the labs, and he introduced me or the possibility to do it in Oleg's group. This group is known to use crazy advanced microscopy resolution techniques, and they are also really good at working with mitochondria and stainings and changes in potential, in mitochondrial potential. So it was kind of the perfect match. So we decided to contact Oleg, and he was happy to have me there. And I'm very lucky because in 2 weeks, I learned a lot of things. So the first thing we did is we needed to develop a knockdown in vitro model. And we did it for NRF2 and KEAP1 using lipofectamine 3000 protocol. And we saw by Western blot, so by protein analysis, that our knockdown was good, and the best one was at the second day at 24 hours. Once we had the cells that we use, HepG2 cells and Alexander cells, we induced oxidative stress. And as I told you, we wanted to do an acute model. So we use a PAP, which is paracetamol, or D-galactosamine plus LPS during 24 hours of treatment. After this period of time, we studied the mitochondrial morphology and membrane potential changes in both models, so the knockdown for NRF2 and the knockdown for KEAP1, and in both cell lines. All of this, I did it new. So this is, like, for me, was new. So this is the importance of the short-term scientific missions and internships. So I get to use HepG2 cells and Alexander cells that I never did before. Also, I learned how to do the transfection protocol. It's true that I didn't have a lot of time to practice, but at least you see it, and you get a lot of feedback and a lot of resources from people that already did it. And it's not a protocol that you just check online. You get tips and advice from them. So it was really nice. And I have to thank Maria and Barbara and Adam for this, because they were amazing. Also, I never did a treatment in cells, so they were also very helpful on this. And we study viability, which of course I never did. And finally, I was really interested in how they perform cell labeling, and we saw the results in super resolution microscopy, which I tell you now, it was amazing. These are some results. I'm not going to get deep into this and the conclusions that we got, just to show you how cool these pictures are and how much information you can get from this. So this is how the mitochondria looks like in a wild type cell lines in Alexander and FG2. This is how it looks when you knock down NRF2, and this is how it looks when you do a knockdown of KEAP1. So the changes are quite visible, and it provides helpful information and for my project in that moment. But we also check the mitochondrial membrane potential, and we found interesting results as well. So with this staining with this JC1, you can see by calculating the difference between the green fluorescent and red fluorescent, how is the mitochondrial potential at that moment. I'm not an expert, and as I told you, I did it only for a short time, but if you are more interested in this, I'm sure that Oleg can answer any question about super resolution microscopy or about anything related with these techniques. And this was, in my opinion, the thing I was more interested when I did this short-term scientific mission. It was the basal oxidative stress stage of my cells at that moment. I know that these cells were not belonging to mice, so they are not primary mouse hepatocytes, but it gives you a hint of what happens when you turn up or you turn off some genes in the cells. So the interesting thing is that we saw that in any case, when we did the knockdown for KEAP1, we got a reduction of the total ROX production. And the interesting thing was that this was mainly due to the superoxide levels because of the staining that I showed you before. I'm sorry, I didn't say here. This belongs to the superoxide production, and this is the total ROX production. There are two different things. So this gave me available information, and it helped me a lot to see which path I should take for my project, which is staining we should do, on ideas for more experiments. And what are the benefits of doing a short-term scientific mission? First is learning crazy technology and methods that you normally don't have reachable by hand. They had this massive microscopy that it was honestly the best thing I saw ever. They won prizes because of recording cell videos with this. So it was crazy. Also, you get to do some networking. I had a really nice time with Maria, Barbara, and Adam. They took me to local bars and restaurants, and we had a good time, even though it was only 2 weeks. So you do a lot of networking. I keep being in touch with them by Twitter, Instagram, and all the social media. So it's always very helpful if you need a hand. Now that I'm also working with cells again and discover new places, you get the chance to travel. So these are the benefits, and how to apply. Okay. I'm sorry. I think this moved. But you need to go to the Cause Action website, and if you scroll down up to the bottom, you will see this link here. And then if you access to it, you get to the index, and it's the section 8 where you can find the information for the certain scientific mission. This was, yes, here it is. This was updated in April 2021. I don't know whether this is going to be possible because of the current pandemic. I don't know if you remember the coronavirus. But if it is, I really encourage you to do it, to have a look and see if you are interested in be part of this experience. And this. This for me as a student, it was very important because sometimes when you do an internship or an Erasmus program, you find that there is not enough money to live and to study. And with these short-term scientific missions, you don't get that. There is enough money for doing the whatever you want to do, and in a really easy and way, because honestly, for me, it was very nice experience, and I did not feel the pressure of, okay, today I should go really low in my money or anything like that. So I found that it's minimum 5 days. You can do these short-term scientific missions in 5 days. I did it in 2 weeks, but you can go up to 6 months. The only thing is that there is a maximum amount of money of 3,500 euros. But it will depend also in the country that you choose and obviously the period of time that you decided to do. And this is also something that you need to consider when you do this internship, is that you pay for everything in advance. And then when you get in there, the first day, you complete a formula, a form that says that you are there and that you started your project. And then the cost action will give you the 50% of the money that you pay. And once you are back, and then you do the inform of what you learn and the techniques and so on, then you get the rest of the money. This was really easy for me, and I did not have any other problem. So I hope with my talk, I encourage you to do these kind of internships. Really, thank you so much for listening. And I know it was a different talk of maybe for what you are used to, because I didn't show any results. But if you want and you're interested in any of the projects I show you, you can contact Javier Cubero or Laura, Laura Moran, which I think is also in the audience, and obviously Oleg. So thank you very much, and I'm happy to take any questions that you may have.
Thank you, Nuria. I think it was really nice talk. I would have put it the same way as you did. So I think you did great. This is, I think, what we wanted actually to show, that it's possible to learn some techniques, specifically in a different lab of the cost action, and I think it's very nice. So Oleg, that you are there. Maybe also Gareth, if you as early career investigator co-coordinator, you can also intervene whenever you want. But maybe Oleg, you want to comment something before we start with the discussion?
Actually, very nice presentation. Nothing to add.
I didn't know that you also took Nuria out at night, but she never told me about this.
Of course, you go to Prague, and if you don't go out.
Of course, Prague is a really nice, it's a lovely city.
Yes, it is.
There are two questions from the audience. One of them is from Marina from Malaga, from Marina Villanueva. She says that she mentions that the pictures are really nice. And what is your opinion whether mitochondrial isolation or network disruption were related to mitophagy activation?
We thought about that, and we wanted to do more experiments about mitochondrial fusion and so on, but we could not get to the point of doing that. So I cannot say that. I'm really out of the topic now. I'm super sorry. Maybe Cubero, maybe you can answer this question better than me.
Yes, I think it's a great question actually, because what you show, I mean, obviously KEEP and NRF2 are sensors of oxidative stress, and they get really in theory, NRF2, as you say, in theory, NRF2, when you get a stress such as acetaminophen, like a PAP or CCL4 or any other toxic or any other stressor, like high-fat diets, for example, we would expect that it goes on transactivating to the nuclei and starts like to control this ARE response, the antioxidant response elements, such as hemooxygenase 1, etc. All these enzymes. But obviously, KEAP1 is very important for mitochondrial damage. So when you move, change a little bit the configuration of the protein, the mitochondria completely changes. We haven't checked mitophagy, but I think Oleg, you did some mitosocs, right, in Prague, or with the knockdown, or I think we were talking about this sometime.
Yeah, COX. We were checking for the COX.
Or COX, down. Exactly.
Yeah,
exactly.
Yeah, was down regulated. Yeah, but we didn't get to the point of the mitophagy to cross check. Yeah, that's what we are. That's nice. Nice thing to consider.
Yes, we mentioned this in the last meeting that we had. So yeah, so Marina, I think that this is a great question. I think we have to go a little bit into detail with these results. There is another question from Carlos Lopez Gomez. He says that also that the pictures are really nice, and that we should also check the expression of mitochondrial dynamics genes and proteins. Yeah, exactly. I also agree. This may unravel interesting results. Again, Marina says that whether mitophagy activation is due to superoxide accumulation. In this case, I don't know. I mean, do you have any comment on this, Nuria? Whether mitophagy is related to the generation of superoxide radicals?
I don't know. I haven't worked in oxidative stress for a long time after COVID. Maybe Laura, if she's in the audience, maybe she can talk about this. Laura, I'm dragging you here.
Well, if Laura wants to intervene, but I would say that I think not directly. Superoxide might trigger the activation of JNK and then the translocation into the mitochondrial membrane, the alteration of the membrane potential. But superoxide should only be it's like what is first, the chicken or the egg, no? So whether NRF2 gets transactivated because superoxide and then it causes out mitophagy, or vice versa, no? So it's a consequence of the mitophagy and the apoptosis of the cell. This we have to see. Laura says that she's mute. She can't talk. Oh, Gareth, you can't talk either. You don't have the right to talk.
I think I can talk. Yeah,
yeah, sure. That's great. Yeah.
So did the overall mitochondrial mass change? Because obviously, then you can obviously with mitophagy, you're getting basically turnover of mitochondria, but obviously it's just the shape that was changing from like filamentous to, the very round, sort of look almost like glycolytic sort of mitochondria. So, but did the overall mass change of mitochondria?
We didn't check this. We didn't check this in Madrid, but you didn't also check it, right? In Prague.
No, we didn't check it. Yeah.
This would be a good idea. I mean, with the equipment that Oleg had in Prague, we could do very nice confocal studies.
So we already have IPS lines as well, which have mitophagy reporters established already, so you can quite quickly test that, I expect.
Okay.
So might be, if you're interested.
yeah, for sure. I mean, this we have to take it into account because these IPSCs that you have are an amazing tool for the whole consortium that we are, no? So I think this is very, very nice.
I should say it's very nice talking Nuria as well. I enjoyed it a lot.
Oh, thank you.
So any other question from the audience? No more questions, Maribel. You have any comment?
Oh, she's muted.
You
need to activate the now. Perfect.
Now, perfect. Well, I have to congratulate Nuria for what she
was able to do just in 2 weeks. So
yeah,
imagine,
I had a lot of help.
yes, but imagine 1 month. And your data, particularly the graphs, have been so exciting indeed that I think that we are, you are showing the importance of collaboration with a different area, totally different, with Oleg, which is, who you are physics, aren't you, Oleg?
Partially, I know. I'm cell biologist.
Okay.
I'm just in the Institute of Physics because it's nice to use here good tools. Nuria showed only a little part of the what can be done. I can show more if someone is interested.
Yes, for sure, because Marina, you could tell that we are willing to. Do you want to comment, Marina, a little bit on what we are about to start?
Hi. Yeah, of course. Very nice talk, Nuria. Was great. Well, we're trying to isolate skin cells from patients with drug-induced liver injury, and we want to see if we can see this the effect of some drugs in the skin cells instead of hepatic cells, because it's not mandatory biopsy of the liver in these patients. So one of the things we want to see is mitochondrial dysfunction, oxidative stress in these keratinocytes or fibroblasts from these patients. So I also was working before starting in Maribel's lab in autophagy and mitophagy and mitochondrial diseases. So the link between liver diseases, mitochondrial dysfunction, if autophagy is a protective, has a protective role or detrimental role in the diseases, we are so interested in that. So that was my interest in know if this mitochondrial isolation was the initiation of mitophagy to improve the bioenergetics of the cells or not. So yeah, we are so excited to start for starting this project, and we also want to collaborate with all of you if you're interested with us. Thank you.
That's awesome. I think Oleg, you have a good target in Marina, because you can visualize this much better than anyone else.
Yeah, be really interested in doing the future a shorter scientific mission, of course. Also, other members of my lab which are collaborated with me, they are so interested in do that.
Excellent, excellent.
Thank
I just
you.
want to comment on the short-term scientific missions. Is that the funding, it depends on the age. So when these amounts that we were discussing, or Nuria was discussing, depend on whether you are a young investigator or not. So you can get the maximum amount if you are a young investigator, because what the cost action wants is to favor the young people and the mobility within the groups to a different country specifically. So you just need to prepare a very, very short but focused abstract. You get the permission from the host institution, from your institution, a letter as well from your IP, and with all these documents, you can already apply. Okay, so from my side, I think it was really nice talk today. The next talk, as I mentioned, it will be the 15th of July, yeah, at 4:30 at the same time. And then this day, Ismael Alvarez and How New from the University of Malaga and the Biomedical Research and the IBIMA, they will discuss on clinical trials and drug-induced liver injury. What we have learned are where we can go. So please don't miss this nice opportunity also to study a little bit more on clinical trials of Andili. It's a great opportunity, and this will happen next month on the 15th of July at the same time as today, as 4:30. So until then, I want to thank you for being here today, and we will see you very soon.